Now we move on to the second part of the question, that is finding out the index error. Now, the reason why a cogged hat is formed when we take three celestial position lines is due to an error. If there is no error, then all the three position lines would intersect at the same point, and there will be no triangle or no cogged hat formed. The triangle or cogged hat is formed only when there is an error in the observation, plotting, or calculation of the site. Now, we have learned how to resolve this cogged hat in two different scenarios: when the bearings are contained within 180 degrees and when the bearings are outside or not contained within 180 degrees. Now, in some of the questions, they will also ask you to find out the magnitude of the error which was present in the observation. So how do we find out this error? Now, for finding out this error, you have to pick up any of the position lines. Any of the three PLs, any one of the three PLs can be picked up. For our example, let's pick up the first position line, the red color PL. We can use any of the position lines to find out the error. So in the example, we are using our first position line to find out what the error was. Now we have to draw a line which is parallel to this PL, parallel to the red color PL, and passing from the fix. So we pick up our parallel ruler or sliding ruler or set square, whatever tool you are using, and align it with our first PL, the red color PL, shift it, transfer it to pass from the fix, and then draw a parallel line. Let's draw the parallel line in our plot. You can see the parallel line passing from the fix now. Now this line which we have drawn would be the accurate position line without any error, because this is the PL which is passing from the actual position of the ship. The red color PL had some error in it, and the maroon color PL which we have drawn now passing from the fix is the accurate PL or the exact PL without any error. Now once we have these two parallel lines in our plot, we have to find out the distance between these two parallel lines. The distance between these two parallel lines gives us the error in our site. So you can see this is the distance between the two parallel lines or the two position lines. This distance can be measured off using the scale on which this plot is made. So you can read off what is the distance between these two parallel lines. This gives us the index error. So as you can see in the plot, this distance between the two parallel lines is the index error what we are looking for. This can be done with any of the three position lines. Irrespective of whichever position line you use, you will be getting the same index error. Whether you use the blue color PL, draw a parallel line here and find out the difference, or you use the green color PL, draw a parallel line and find out the difference, the index error will be the same in all the cases. Reason being, this point which we have found, that is our fix. As per geometry, this point is equidistant from all the three sides of the triangle. So whether you find out the distance to the red PL or the blue PL or the green PL, in all the cases, the index error will remain the same. The point where the angle bisectors of a triangle meet is equidistant from all the three sides of the triangle. Okay, now we have obtained the magnitude of the index error. Now the second thing which we need to find, what is the sign of the index error? We know the index error of the sextant can be on the arc or it can be off the arc.
Now, beta, before going into the sign, up to here, if there's any doubt in your mind, just let me know.
सर यहाँ पे हम लोग ने ऐसा रीजन इंडेक्स एरर का दिया है, तो सर रीजन तो कुछ और भी हो सकता है कि ये खाली इंडेक्स एरर ही होता है?
ओके बेटा, और क्या रीजन हो सकता है? कुछ एग्जांपल दो मुझे।
तो सेक्सटेंट में अगर कुछ दूसरे एरर्स हैं या कुछ।
सेक्सटेंट की तो बेटा सारी की सारी एरर इंडेक्स एरर में कवर हो जाती है।
कंपास बियरिंग कुछ गलत लगाई है तो
हमने इसमें कंपास बियरिंग हमने यूज ही नहीं की बेटा। हमने तो
टेरेस्ट्रियल में करते हैं यार।
राइट, हमने तो तीनों के एजीमुथ एबीसी मेथड से कैलकुलेट किए हैं, सो दे वुड बी करेक्ट।
डिप करेक्शन वगैरह भी सर कवर हो जाती है।
डिप करेक्शन, यस,
डिप करेक्शन,
राइट बेटा। डिप करेक्शन की जो एरर है वो इसमें आ सकती है। वो कैसे आ सकती है? लेट्स से यू टुक ए साइट, स्टार साइट, आपने 3 पीएल्स निकाली और जब आपने इसको वर्कआउट किया तो कॉक्ड हेड बन गई, एंड देन व्हेन यू चेकड अप यू कुड रियलाइज अब डिप करेक्शन के लिए हमें हाइट ऑफ आई यूज करनी है। height of eye is given to you, usually it is pasted on the bridge. What is the height of eye? अब आपने वहाँ से height of eye पिक करके अपनी साइट को वर्कआउट कर लिया, बट लेटर ऑन यू रियलाइज्ड कि आपने जो height of eye पिक की थी वो तो बैलेस्ट पैसेज की थी, बट जो एक्चुअल शिप का पैसेज है वो तो लोडेड पैसेज है, सो height of eye was different. So because of that the error could be generated. सो अगर ये डिप करेक्शन की वजह से एरर आई है तो यही जो डिफरेंस आप निकालोगे बिटवीन द रेड पीएल एंड द मैरून पीएल, दिस विल बी द डिप करेक्शन. So instead of index error, the same error would represent the dip correction in that case. And अगर ये dip correction है, then you can go into the dip correction table. And if they have told you that, let us say the observer forgot to put the dip correction, then you can take this dip correction to the table and you can also find out what was the height of eye of the observer. ये भी पता कर सकते हो आप।
सर इस केस में सर ये ऑन द आर्क होगी ना सर ये एरर?
ओके बेटा, मैं अभी बताता हूँ कि ऑन द आर्क और ऑफ द आर्क हम लोग कैसे चेक करते हैं। सो आई विल एक्सप्लेन टू यू इन डिटेल. अदर देन दैट, एनी मोर डाउट?
this will give us sir dip correction in meters.
Ask again beta.
This distance will give us dip correction in meters, ना?
आप बेटा यहाँ से जो प्लॉट से आपको मिलेगा वो तो डिप करेक्शन होगी। आप जब डिप करेक्शन के टेबल में जाओगे तो उसके अगेंस्ट अपनी हाइट ऑफ आई चेक कर सकते हो। वो हाइट ऑफ आई मीटर्स में भी निकाल सकते हो। इफ यू वांट यू कैन गेट इट इन फीट आल्सो।
Sir, जैसे the distance for this index error is 5 miles, sir. So that will be like 5 minutes.
Yes, beta. 1 minute is equal to 1 nautical mile. So if you get as 5 miles, yeah, that means the index error is 5 minutes.
Okay, sir.
Okay. So is it clear now, beta? Other than index error and dip correction, there could be no other error in the site, which is a similar error in all the three observations. इसको छोड़ के अगर
सर
कोई
अगर
और error
जीएमटी
होती, हाँ हाँ
सर
बेटा
अगर
बता।
जीएमटी हमें सर लिया गलत तो
ओके
सर अगर
बेटा,
हमने
उस केस में
जीएमटी
भी
मतलब समय गलत लिया
यूनिफॉर्म एरर नहीं होगी, उस केस में भी एरर अलग हो जाएगी, बिकॉज तीनों बॉडीज, लेट अस से आपने 5 मिनट की एरर ले ली टाइम में। अब 5 मिनट में तीनों के तीनों स्टार अलग अलग रेट के साथ अपना एजीमुथ और एल्टीट्यूड चेंज करेंगे। The rate at which the bodies change their altitude and change their azimuth is not same for all the bodies. It keeps on changing. So ऐसे केस में अगर हमने टाइम में एरर ले ली है तो फिर हम कॉग्ड हैट को रिजॉल्व नहीं कर पाएंगे, because it will not be a similar error in all the three observations.
ओके सर।
ओके ऐसे केस में तो फिर बेटा हमें करेक्ट टाइम अगर पता है तो उसके साथ से दोबारा साइट को वर्कआउट करना पड़ेगा, और अगर नहीं पता है तो हमें दोबारा से साइट लेनी पड़ेगी।
यस सर।
ओके, so shall we move on to the sign of the index error now?
Yes, sir.
Okay.
So how do we find out whether this index error was on or off? Let's see. Now to find the sign of the index error, we have to check that when we are moving from the wrong PL, by wrong PL, I mean the PL having error, which in our case is the red position line, which formed one side of the triangle. So when you are moving from the wrong PL, that is the red PL, to the accurate PL, the accurate PL is the maroon color position line, because it is the PL which is passing exactly from the fix. That's how the position line should be if it is accurately calculated. So when you are moving from the wrong PL, that is the red color PL, to the accurate PL, that is the maroon color PL, you have to see carefully whether you are going away from the body or you are going towards the body. Which body we are talking about? The body, the celestial body using which the PL was calculated. In our case, this celestial body is the red color star, that is star 1. So when we are moving from the red PL towards the accurate PL, that is the maroon color PL passing from the fix, are we going away from star 1 or towards star 1? So you can see this arrow indicates the direction in which we are moving, and it is very much clear that we are moving away from the celestial body, in this case the red color star 1. So in our case here, we are moving away from the body. Now, moving away from the body, what does that mean? If you are moving away from the body, that means the true zenith distance of the body should increase. Zenith distance is basically the distance or the arc between the zenith of the observer, which is represented by the position, and the celestial body. So if you are moving away from the star, that means the zenith distance of the body should also increase. Now we know that true zenith distance is 90 minus true altitude. So if we want the true zenith distance to increase, then the true altitude should be decreasing. If the true altitude decreases, then 90 minus true altitude, that is the true zenith distance, it is going to increase. And if the true zenith distance increases, this red PL will move towards the maroon color PL and it will become accurate. So we want the true altitude to decrease. Now for true altitude to decrease, the correction which we are applying should be negative. The correction which we are applying to the true altitude should be negative. So this tells us that the index error which we are applying in this case should be negative. Now index error is negative if it is on the arc. So when we are doing altitude correction, if the index error is on the arc, we subtract it. So the index error in this case is on the arc, so we will be subtracting it. When you subtract it, the true altitude would decrease. The value of the true altitude would be lesser. When true altitude decreases, the true zenith distance value would automatically increase. And this red color PL, which was having an error, will be corrected and you will have the accurate PL, which is the maroon color PL passing from the fix. So I'm going to repeat it once. The first thing which you have to see is when you are moving from the wrong PL or the PL having error to the accurate PL or the PL passing from the fix, are you moving away from the body or towards the body? In this case, we are moving away from the body. Moving away from the body, the true zenith distance should increase, which it can do only when the true altitude reduces or decreases. The true altitude would decrease when you have a negative correction, and a negative correction occurs when the index error is on the arc.
Okay, so beta, have a good look at the diagram now and let me know the doubts in your mind.
सर इस केस में तो सर जो अपना जो ट्रांसफर किया है सर वो हमेशा अवे ही होगा ना, क्योंकि अगर टुवर्ड्स होगा तो फिर हमको फिक्स नहीं मिलेगी.
That's right, बेटा, but ऐसा भी possible है किसी केस में that when you are going from the wrong PL to the accurate PL, you may be moving closer to the body. अब इसी केस में अगर स्टार का azimuth let us say 220 होता, the azimuth of the star was 220 and this intercept was away. So in that case, when you go from wrong PL to right PL, you will be moving towards the body. Okay, तो वैसा भी हो सकता है. It all depends upon the situation. What is the azimuth of the star? How is the cocked hat being made?
ओके सर.
Okay. और बेटा और कोई डाउट आ रहा है माइंड में?
ये तो सर ये केस हो गया कि व्हेन ऑल द थ्री स्टार अपार्ट फ्रॉम वन मोर देन 180 डिग्री सर. अगर तीनों स्टार सर जो सेकंड केस में था उसमें रहेंगे फिर?
बेटा exactly the same method applies there. Exactly same method. If you want, I will show you. Just give me a minute. This was the diagram for bearing stretch contained within 180. So ये हमारी फिक्स है. अब आपको इन तीनों में से कोई भी एक PL सिलेक्ट करनी है. Which PL you want to select, बेटा?
ब्लू कर लो सर.
Okay.
ब्लू नहीं सर, ये कर लो, ग्रीन साइड वाली कर लो सर, ग्रीन.
Right, बेटा, right. So let's say you select the green position line. अब हमें इसी position line के parallel एक line draw करनी है passing from the fix. So you draw a parallel line passing from the fix. then you measure the distance between these two. That will give you the magnitude of the index error. Now to find out the sign of the index error, you see, when you go from the wrong PL to the accurate PL, are you going towards the star or away from the star?
Away from the star.
Right. So in this case also you are going away from the star. That means TZD should increase. TZD can only increase if the true altitude decreases. For true altitude to decrease, index error should be on the arc, because then it will be negative, which will reduce the true altitude. Okay, beta, all right.
Oh, yes.
So whether you have bearing stretch within 180 or outside 180, in both the cases, the method or the procedure remains the same. Okay. So any other doubt, beta?
No, sir.
Okay, ठीक है. So cocked hat is done, beta. So